Welcome everybody to Dallas Personal Robotics Group Robot Builders Night Virtual for March 31st, 2026. Tonight we'll do our normal robot presentations and then open the floor up for any questions or discussions. Couple announcements. First announcement is our club competition, Roboama, coming up in May 24th weekend, I believe. May 23rd. And during the competition, we will have quick trip, line following advanced, barrel racing, 6-can, 4-square, and sumo. Competition will take place at the Dallas Makerspace, and there'll be further announcements on our website or on the Discord server. So keep an eye out for that. Also, a couple of the club members are participating in a robot parade. They've been building a robot, and the robot tows a little float, and it will be judged. The robots follow each other along a line following course, and they have to keep a distance between them and the float in front. This will be held in April, but I don't have the date. So,
this says Saturday, April 11th. I don't know if that's right, though.
Well, that's probably right. So, okay. April 11th. So I know that a couple club members have been building a robot to compete.
Yeah. So
we look forward to seeing that competition. For presenters, first up we have Matthew. Matthew is going to give us an update on how his Micromouse robot performed.
Well, it performed. It didn't go very well, but so I'll try to tell the story. So it's been a long time since I've joined on one of these meetings, so I'll just give a quick update of what I was trying to accomplish. So first of all, this was just to get my foot in the door. They have a lot of really fast robots, a lot of really sophisticated robots there, and this wasn't really designed to do any of that. You know, the fast robots are going to have vacuum fans to suck them down to the ground so they can take turns at 6 Gs and move at insane speeds. This it did not have any of that. So yeah, so this is the robot that I built. It's a pretty standard non-competitive design. It just has the 2 wheels and the 4 sensors on the front.
Are you presenting something, Matthew?
Oh no, I forgot to share my screen. I'm sorry. Yeah, this would have made a lot more sense with the screen on.
So are you saying you're like 4th out of 4 contestants?
So they had about 15 people, about 10 or no, they had about 20 contestants, I think. About probably about 10 to 15 didn't even finish, and I was among them. Can you see my screen now?
No, we still cannot see your screen.
It says it's sharing.
Don't believe it. It's not. Did you do like a window or entire screen or?
I know that guy. He lies all the time.
It's grayed out.
Try it again.
Your microphone got muted, Matthew.
Rejoin.
Okay. Please stand by for technical difficulties. You're back, Matthew.
Okay. Now can
There you go.
screen?
Yay, infinite screen.
All right. Okay. Can you see it now?
We can see an infinity screen.
Oh no, come on. It's not sharing the window, it's sharing just
It's sharing. Well, it looks like it's sharing a screen.
I
Oh,
want to
you're-
share the whole screen. Oh, here we go. Is this better? Can you see some pictures now?
We see an array.
Yep.
of-
Yes. Mhm.
Okay. Cool. Okay, so this is the robot that I built. It has the 4 sensors on the front and the 2 wheels on the side. This is the same thing that I've presented a couple times in the past.
Mhm.
So on the day of the competition, I get there. It looks like this, and they have the maze set up and it has a couple of partitions that you can use to practice on. See, they have some blocked out areas. So I ran a couple of test runs, and as expected, I was running into a few different problems. I would start the robot off, and it would slowly work its way towards the wall. There was some problem with the way it was centering itself, so it kept getting off. And this is exactly what happened during the competition as well. So I expected that to happen. I've got some issues with my sensors, but I'm working on fixing those right now. But I do want to show you a video of someone else's robot. I hope it comes through over the screen share. But this guy, his robot is so insanely fast. I hope you caught that.
Just saw it go by the corner.
Yeah, I saw
Exactly.
a blur. Yeah.
Yeah. But so the level of competition is quite high. I took a few pictures of some of the more interesting robots. This guy,
Mhm.
he likes to
Back
do
to the
models.
future, huh?
Yeah. This guy was really small. It was about the size of an Apple AirPods case, but slightly longer. This guy was on standard size. This one actually won the competition based on overall score. He's been competing for decades, and this exact robot has competed for 10 plus years, and it looks like it hasn't really changed too much. This is from the Spanish team. They flew all the way from Spain.
Wow.
And this is from one of the Japanese teams, and it actually had the fastest run. It was like 6 seconds.
Mhm.
This is a different angle of the previous robot that I showed a few slides back.
So why didn't the Japanese win?
So they have a scoring system based on how long you search the maze and how fast you run the final speed runs. And there's a formula.
Got
They
it.
also,
So they had a longer search phase, probably.
yeah, something like that. They also have a penalty if you have to touch the robot. So if it crashes and you have to help it out, or if it just stops. They had a large percentage of competitors that just, their bots just stopped because they had a bug or they kept crashing in the same spot. So I learned that if you can just finish, you'll probably finish in the top 10, maybe even top 5, depending on how many people are there.
Even running as slow as yours was running?
Oh yeah, yeah. They had this one guy whose bot was doing awesome, but he crashed in the exact same spot in the maze every single time, and it was very likely due to a bug in his code that told the robot to keep moving forward when they actually had a wall. So if you can just to polish up the search algorithm, you'll probably do have to send. All right. Oh, what else do we have? And this is just a picture during the competition. So it had a decent crowd. The competition takes place at APEC. It's the Applied Power Electronics Conference. It's a big industry conference where companies like Microchip, TI, Renesas, and all of the people are going to be there. So they are just doing their conference, and the Micromouse is happening in the background. But they had a lot of people watching, so it was a lot of fun. They had a lot of people who are really interested in the small and nerdy things that you don't get to talk about too much at work, like how to optimize the circuit or how to optimize the software. It's a lot of fun.
So I noticed in the maze there was little tiny spikes. I guess those are hard to detect.
Oh yeah. So typically in the competition maze, they don't have these freestanding nodes. The nodes are just there to attach the wall pieces to. They can have them in the competition maze, but they usually don't. I don't think I have a picture of the full competition maze. Let me see if I do. I guess you can kind of see it in this angle, but you see how there's no freestanding spikes except for the one in the very center, which are the target squares. I should have taken a picture of the maze configuration. I'll have to ask him to send it over email. But those are the pictures from the event. Now, after about 24 hours of being home, I had restarted the design for the Micromouse, and I kind of went back to square one. One of the major issues that I had was the behavior of my sensors, which is this bottom part here that has the photodiode and the op amp. I think on what happened was I didn't have enough gain, or I didn't have enough reflected light. So the signal to noise ratio was very bad, and I only had about 200 ADC codes of difference between wall and no wall. And the entire range of my ADC is 4096. So it was a very small portion of that range. So that means that any noise, either from the environment or on my board, would trick the robot into thinking that there is a wall when there's not, or vice versa. And that plagued me for weeks and weeks, and eventually caused the downfall at the competition, I think. So I've been spending the past few days, this keeps on going back. I've been spending the past few days working on a new and improved circuit here that has better bandwidth. And I've been simulating different values of resistors, and I'm trying to figure out how to properly design the circuit this time. That's going well. I do need to take some more readings of the photodiodes just to make sure that I know exactly how much current they're going to produce. But I can do a detailed presentation on this in the next few weeks if y'all are interested. I have also started working on the PCB. I'm taking a much different approach to it this time. Instead of making the whole chassis the PCB, I'm only going to have the brains and the sensors on the circuit board. And the motors are probably going to be mounted to a separate 3D printed chassis to help reduce weight. So everything is more tightly spaced this time.
Where's your suction fan?
That's going to be mounted to the chassis.
Ah.
Yeah, so not the PCB. You can think of it as, I don't have a good way of drawing a picture. Is there like a paint program on Macs? I just got a MacBook Pro a few months ago. So think of it like this. So here's the chassis. I'll just quickly do a thing, and then maybe here's the the wheel. The sensor board is going to be mounted on the front here, and then maybe we'll have our fan here with the fan motor here, and then the battery is going to be mounted like between the two wheels there. So the entire bottom of this chassis is going to be contacting the ground, probably with some kind of a plastic or rubber skirt. So I hope it weighs a whole lot less than using a PCB material for the entire chassis.
And I noticed on some of those robots they had a vertical motor. So that's the fan motor?
Correct.
Okay.
So this is
Seems
where
like
I am
that fan motor
today.
might take a lot of power to run.
Yeah, and some people even run their fan motor during the search too because they're searching so fast. Yeah, the fastest robots would search the maze faster than the slower robots ran their speed runs. So that was fun to see.
Mm-hmm. I also noticed that your sensors were angled like a lot of the other robot sensors. So is that sort of a common arrangement where they're at oblique angles?
Yeah. So a good example is this guy right here. He has these two front-facing ones. Those are used for seeing if they have a wall directly in front of the robot, and also for staying centered on going diagonally down cells. And then the side-facing ones are used for detecting wall edges and for seeing if there's walls to the left or right. And they're also used for steering. On my new one, I've got some interesting ideas. You may have noticed that there's 7 sensor ports here. I'm going to have the 2 facing forward, and then I'm going to have a pair facing left and right. And the reason for that is I can use the front sensor to scan for a disappearing wall. So, and then the back sensor can be used for actually steering the robot. So if the front sensor sees that the wall is starting to disappear, it can stop using that back sensor for steering. So the idea is that it is always steering using valid data. If a wall is disappearing, it can switch to a different reference source, maybe the right wall only instead of just the left wall. And then I have a sensor in the center. I'm not convinced I'm going to use this one, but the idea is to, here, I'll draw a picture since it's going to make more sense. This top square here is a cell, right? This is the same dimensions as the competition maze. So if your robot is approaching a wall, like this, and you're using your side-facing sensors, you might start to get some reflections, especially as you get closer to the wall. Or if you're misaligned, it could cause some really weird data. So by having a separate front-facing sensor, it brings it much closer to the center line. So hopefully, the quality of data is much higher than if you were using the left and right. I might be over-engineering it, but it's something that I want to try just to, just as an experiment. I don't actually have to use it. I'll have the parts there. Why not try it? What else is new? I want to add some Bluetooth to it. They had this one guy that was controlling his robot from his phone, so he could start it, he could stop it, he could send data or receive data. And I think that would be very useful during testing. You could send parameters, you could send different maze configurations, you could receive some telemetry to see if what's breaking or what the robot is thinking. I think that could be useful. So I've reserved some space here. Again, that adds a lot of complexity, but we'll see. And then finally, the new thing on this board is this EPROM, just an external memory. So I can record settings, I could record maze configurations, I could keep a log of all of the commands that the robot is executing. So let's say I'm in the competition and the robot is moving and it hits a wall. I could have that data sent to my computer and then reconstruct what happened, like the black box on an airplane. That was a major problem with the robot that I just built. It was very hard to debug because I didn't really have a serial interface. I just had the debug port, which is helpful, but it's limited. Oh, and I've added some buttons. I didn't really have those on the last robot, so now I can tell it to reset or reset the maze or start the speed run, start the search run. So there's a lot more components on this one. But I'm trying to get a head start. We have 342 days until the next competition.
That's optimistic. I like that. You didn't fail. You have 342 more days to prepare to compete for the second one.
Yeah. Oh, and I'm building a better test maze. Actually, my dad is building it for me. But my test maze was really, really bad in that picture. It was just some cardboard, and that is another reason this was so difficult to test. Where's a good picture of it? I think I just have a video.
Why would cardboard be bad?
Because
Less reflectivity, probably.
well, primarily because they weren't the same thickness as the competition on pieces, so I had to recalibrate, so I had to recalibrate everything for the competition. The walls are 1.2 centimeters thick, but the cardboard is just a few millimeters.
So so you can't see the edge of the wall, I guess.
Yeah, it just the difference in thickness just adds up to a large error over time.
Okay.
But I have a lot of grandiose plans for next year. So we'll see how those come together. But yeah, that's all I had for today.
Was anybody successful in completing the whole thing?
Yeah, they had like 4 or 5 people that completed it.
One of them had been running the contest for 10 years, though.
Well, they had people there that have been doing this since the 80s, like the late 80s.
Back in the day when you timed the event with a calendar.
Yeah.
Instead of a watch.
Well, now they have these laser sensors in the start square and end square. So it starts after you cross the starting line and it ends after you cross the finish line. The difference between first and second place was like 200 milliseconds.
Oh, wow.
Just like the Olympics, right?
Yeah, so so this guy was 200 milliseconds slower than this guy.
These are university teams that are competing, or just individuals from other countries?
It's a good mix. They had a lot of university teams, but I think all the fastest robots were individual people.
Okay. Did you get to talk to a lot of people and figure out some new strategies and what works, what doesn't work with the robots, that sort of thing?
Yeah. So one thing that I learned when this competition was getting started, people went from 2 wheels, and then they increased to 4 wheels, and then 6, sometimes even 8. But now people are moving back to just 2 wheels like this. When you have 2 wheels, the center of rotation is exactly between the wheels, so there isn't any slip. But when you have 4 wheels, the center of rotation is not aligned with the axles. It's between the 2 axles.
Mm-hmm.
So all of the wheels are slipping during turns, and that can cause some errors in your position that can add up to a crash later down the road. So I was going into this competition assuming that I was going to have mine have 4 wheels, but everyone was saying to just stick with 2 because that's what is more successful now, especially with vacuum fans.
Okay, that's interesting.
I also learned something cool. The laser that they use to record the time is IR, and it has been known to screw up people's sensors. So,
What does it do? Saturate them, or?
yeah. So I need to make sure that that doesn't happen to me. But I don't think it's going to be a problem because my sensors are working in pulse mode.
Mhm.
So it turns on, takes a reading, it turns off and takes a reading, and takes the difference. So even if there is some bias there, it shouldn't really cause a problem.
So it looks like you integrate the photodiode voltage.
Could you repeat that?
It looks like you've got an integrator off the photodiode voltage. Is that right?
No. So let me explain this real quick. Let me take off the noise generator just to make it a bit easier to see. And let's measure the current. So this is the current. It's just a pulse current. It's how long is the pulse? The pulse is 10 microseconds. And then I have a transimpedance amplifier. So the photodiode is a current source. So this circuit up here with the op amp and the capacitor and the resistor is going to convert that current into a voltage. And that is the green line here that we're reading. Let me zoom in on it. So for a 12 microamp current, I'm getting about 1.2 volts. So this is what the ADC can read. I can also add a low pass filter here. And I can clean up some noise. That is what you saw when I had the noise sensor, or not the noise sensor, the noise generator here. And if I rerun it, you'll see that there's some noise. And then the blue low pass filter, the output is smoothing out that noise. So the blue is what the ADC is going, the blue is what the ADC is going to be reading.
So you're using I guess, that value to determine how far you are away from the wall. The more light reflected, the closer you are.
Right. Yeah, exactly. So the thing I don't know right now is exactly how much current on the photodiodes produce when there is a wall and when there is not a wall. I think that's what went wrong on my previous robot. So in the next few weeks, I'm going to set up a test jig and measure exactly how many microamps these photodiodes are producing in the micromouse conditions. And then I'm going to redo these simulations and update the values in my schematic. And then hopefully by then the rest of the layout is going to be complete, and then I can order a test board. The other cool part, yeah, sorry, I keep discovering new things in here. So instead of just using a voltage supply connected to the LED, I have another op amp. Let me move this so it's easier to see.
Oh, is it set up like a constant current drive, maybe?
Exactly.
Yeah.
The Mac version of LT Spice is awful, so just bear with me while I move this thing around so it's easier to see. All right, yeah, so the voltage source here is actually going to be the DAC on the microcontroller. So by adjusting the value of that DAC, I can change the current going through the LEDs. So right now, I have the voltage set to 10 millivolts, and based on the resistor that I have, that it gives me 10 milliamps of current. So I can tweak that for each sensor. I have a mux that is going to every individual sensor. So as I'm tuning the sensors, I can say, okay, give sensor 1 10 milliamps, give sensor 2 a 9.5, and that's just in an effort to balance out the readings. So the whole system here from top to bottom is much more sophisticated, and it's much more flexible.
How much memory are you going to have in your little your black box, whatever it is, an SPIE PROM or?
I just chose a megabit one. It's
okay.
It's probably way too much, but it's like $2, and the package is the same size as like the 128 or even smaller ones. So it's probably the same die. They just put it into a different package and then block off certain sections. So I just got the bigger one. I'm definitely not going to need it all, but it's there if I want it.
So you just keep overwriting for each competition, or do you, seeing how it's big enough, you just clear it and overwrite it all?
So right now, my thought is to have certain partitions. So maybe on one partition, it stores the parameters, like how fast I want it to go. And then I could have like the maze configuration. So every time the robot updates its main, so every time the robot updates its maze in RAM, it's also going to update it in the memory. So if it crashes, I can go and pull that maze config and see if it actually matches what it actually read. And then maybe in a different partition, I could have like the 500 most recent commands. So that should be able to be more than enough to see, the last few commands that were run. As for all of the other memory, I have no idea. We'll have to see what becomes useful.
Definitely looks to be an interesting project.
Yeah, I'm looking forward to it. It's going to be a pretty big one. and I haven't even gotten into the software yet. I've got tons to talk about there, but I'll need to optimize the maze solving algorithm to add all the code to support this new hardware.
I forgot, what is your processor?
It's an STM32G491.
There's so many SD processors now. I haven't kept up with all the newest variations.
Yeah, they had a guy that was running an STM-H. I forget which number, but it was one of the H ones, and he was running at 500 megahertz. It was actually the guy that had the really small robot. It was
probably an H7.
I think so, yeah. It was running at 500 megahertz, which is way overkill, but you know, it's cool.
Yeah, I think that's the same processor they use in the OpenMV H7. So
he even has an SD card. I'm not sure what he's storing on it, but so I'm really looking forward to getting this built and seeing how it performs. I want to have a build done in the next few months, just so I have enough time to tune it. That was the problem with this robot. I didn't have enough time to tune because it had just gotten built a couple months prior to the competition.
So are you mounting the motors to this, or do you have a separate frame? So
It's going to be a separate frame.
A lot of them seem to be like doing a custom PCB as structure and circuit board, or did I misread
Yes. So most people use the PCB as the structure and the circuit board. I'm not going to do that. I'm going to try using a 3D printed frame and then mount the circuit board to that.
Won't a 3D printed frame be too flexible? Even if you use like a CF infused plastic?
I don't think so. If you add the right supports, you know, so let me draw a picture.
Are you also going to add a suction fan?
Oh yeah, for sure. I'm trying to get to my KiCad here.
You can make it with TPUs so that the suction fan can really suck the hard.
Yeah, I was thinking about doing a multi-material print. So let's say you had your structure like this. I'll try to do a 3D little sketch here. If you had your frame here, if that was just a flat piece of plastic, then yeah, it would probably be not too stiff. But you could have these vertical supports, kind of like an I-beam.
You stiffen.
And that would stiffen the frame up quite a bit.
Like a rib to on an airplane, just to stiffen the structure.
Exactly. And then on the bottom, I would have some kind of skirt material that could be a 3D printed TPU, or it could just be like this guy did. This guy just used a DigiKey parts bag, and he cut it to the right shape, and that works too. I don't have a picture of it, but it was pretty cool.
Have you calculated the downforce needed or typical?
I haven't calculated it, but typically it's between 1 and 200 grams.
Over the entire surface of the robot?
Just total downforce. So if you were to put the robot on a table and try to lift it up, it would take about 1 to 200 grams of force to separate the table from the robot. But most people have a limited area. So if you go on Google, you could
So that
see that.
downforce is above and beyond the weight or the gravity of the robot itself.
Right. The bots typically weigh between 80 to 150 grams. I'm trying to find an example of the skirt. Here's one. So the fan is here in the center, and then the plastic skirt helps to seal it. So what I can tell, you have about a 2 or 3 to 1 downforce advantage.
So that's the bottom side of the robot there?
Correct.
Yeah, okay. Huh, and you don't get too much friction from that sucking down to the floor?
Apparently not.
Oh.
You need that skirt to be, because that kind of skirt actually touches the floor unless it has vents.
Right. Yeah. So this is touching the floor.
So it does skid. So it needs to. You can't use TPU there because that would create too much friction. It needs to be a slick surface like nylon or some sort of plastic that would, like PTFE, that would glide.
Self-lubricating.
Yeah.
I was concerned about some gaps in the floor. Do I have a picture? Let's see. Yeah, so if you zoom in here, you can see that they have some pretty large gaps. So if your skirt was too flexible, I could see it getting caught in there and snagging and causing a crash. So you have to be very careful in how you design that, or you could crash because your skirt gets stuck in the crack.
Put a point on it.
Yeah, it's worth thinking about.
I was gonna say that anything with a fan wouldn't fly in our house. We have a bloodhound now that sheds about a puppy's worth of hair every week. So
nice.
So.
I'll have to experiment with different size fans, see what's actually needed. Your audio just cut out.
Froze.
He froze. You have to see what Dyson did for their fan, try to yank one out of a vacuum cleaner and see what it would do.
Yeah, I've been looking at different types of impellers just to see what is out there, and there's a whole ton of different types. So this is going to be fun. I want to minimize the weight and power draw and maximize the amount of downforce. Yeah, this competition is a awesome mix of software engineering, electrical engineering, and mechanical engineering.
I think you just described robotics.
Yeah.
Yeah, but the cool thing about they're just really small. You can't really just solder stuff together. You have to design it really tight.
Yeah, I mean, this was one of the first builds that I did of the bot, and it doesn't really show how small this thing actually is. But those are like standard size LEDs, so it gives you an idea. but I've gone through a few different iterations. This was the first attempt. I screwed up the solder job because I was trying to do it all by hand. This was the next one. And it went much better, but I still had some solder bridging. And then I finally gave up and just had JLC do the assembly, and it came out perfect. But that's the route. So that's the route that I'm going to take with this new one. Well,
So
I guess
the video you showed us, Matthew, was that the actual competition?
no, that was on the test run. I don't have a video of the actual competition, but the actual competition went much worse. It just went a few squares and then stopped. I'm not exactly sure why.
If you had a video, I could give you a gold star.
Oh no. I'm sure it's on YouTube, but don't waste your time. It's not too fun to watch. It just stops after a couple of squares.
Stop. Okay. Well, it's going to be a black star then. Significant progress. You made a lot of good headway on it.
Mm-hmm. But it's not quite there yet.
Yeah, like I say, if we would have had the video, it would be a gold star. Doesn't have to succeed to get a gold star.
I could probably find it. 2026 APEC Micromouse. I went third, so maybe it was there. I don't see the video yet. It'll probably be up later. Well, all right. I think I'll let someone else talk. I think I've been going for like half an hour.
Okay, well, future meeting, if you find it, we can issue it then.
All righty.
That's a very good job, I think.
Well, thanks for listening. It's fun to ramble about this.
Okay, next up we have Ray.
Okay, let's see if I can avoid demo mode here. Okay, so what I've been working on is this is like a previous generation. There was a Pro that was output or created. This is just the Max Cam. So after this one was Max Cam Pro, now there's a Max Cam 2. You can pretty much create a project and load it onto it and run it independent. You know, you don't have to have it tethered by USB to something. Like, for example, and these are all the, these are all the things that, pretty much it comes with. So, yeah, you can do face recognition, face landmarks, face recognizer. This is find blobs. So if I load up find blobs, and right now I have it set up for, I'm looking for, oh, I guess you can't see that, can you? Hold on a second.
How large is the camera itself?
Oh, let's see, here's our ruler. Oh, maybe like 30, almost 40 centimeters by about 60, sorry,
millimeters.
60 millimeters. That's be a big camera. 2 foot, Yeah, so pretty small. It's got a little touchscreen LCD on the back.
Mm-hmm.
And
what processor is driving it?
there are two that God, I used to know what that was. Like an SG 2002, and then another one that they're not, mainstream processors. They're I'd have to look it up. I don't remember what they both are. But one of the things that I can do Let's see. Whoops. Guess I want to shrink that down. And no, I want to get out of that altogether. Go to present a window. And I can't see what that is. Okay. Screen, Microsoft Edge tab. Select tab to share. Okay, guess you can't do that. Window. Entire screen, maybe. Okay, share. And it's not doing anything. Okay, not doing something right here. Just a window. Okay, that's weird. Oh, it's not a Microsoft tab. Oh, let me see if I can do my entire screen then. Okay, I am stuck here. Okay, maybe I can't do this. All right. Share screen. Not letting me select anything. Can't annotate right now. I know that's weird. Well, darn. Okay, I'm going to try entire screen. Because you're screen sharing. Yes, that's true. Show my screen anyway. Okay, there's the infinite screens.
Nope.
Well, I don't know what I'm doing wrong. It's not letting me show a screen. Oh, maybe it's because I didn't have it up at the time. Okay, let's try entire screen. Share. Okay, let's see. And that's infinite. Well, that was what I wanted to show. I don't know what I'm doing wrong here.
Hey Ray, sometimes they have a button in the top right that says share screen. It's a bit hard to see, but that's the one that kept getting me. So if you stop sharing and then try again.
Okay.
I'll try looking toward the top right of your screen.
Okay.
they should have a different purple button. Or else purple for me.
None of those look like that, though. The only choices I have are Microsoft Edge tab, Windows, and entire screen. And I don't want to share a tab. I want to share.
And you've tried share entire screen already?
Yeah, I think that's where I get the. Okay, entire screen. Share. It says picture-in-picture is open because you're screen sharing.
Yeah, so if you click on your application now down below, will it just show that guy?
Let's look here. Do you see that?
Yes.
Yeah.
Ah, finally. Okay. Jesus.
Want to slide it over a little to your left? Yeah.
Yeah, I can blow it up too.
There you go.
Okay. So this, let's see, oh, that was the time of flight example. This one is basically what I use is blob detection to find the cans for 6 can. And what I have is a bunch of thresholds. These thresholds aren't used, they're commented out. So they go from kind of very dim light to much stronger light. And and one of the other things I have to look out for is whether it actually sees a can in the image or not. So what I can do, device disconnected, is connect this. Okay, connection successful. Boom, start running. Okay, and I can make this larger. At least a little bit larger. Let's see if I can get a little larger. Come on. Okay, so you can kind of see the can there. It's highlighting it. And the two numbers on the underneath, the first is the threshold index. So I'm using the first one, or the 0th element of it. And the second one is the X centroid. So if I go over here, the first number should get very low, and go, whoa, froze. Probably a bad connection. Yep, demo mode is in its finest here. Device not connected. Okay, lost connection for some reason. Okay, come on. Now it's not connecting. Okay. Okay. Come on, connect. Well, there we go. Okay, finally. Okay, there it goes again. Okay, so that side of the screen, it should be a very low number. The other side should be about 160 or so, if I can get it all the way over there. So the other thing, it's like if I have another can back there, it's highlighting it, but it's only giving the X coordinate for the larger or the closer one. which is that one right there. So one of the things to test that out, if I can reach it.
That's some strange looking cans.
I don't know if I can get, okay, so see if that one is over there. It should be about in the middle. Nope, it's picking up this one. So maybe that one is actually looking closer. 117. That one over there.
Do
Okay.
you use the area or of the of the blob or the?
Yeah, that's what it should be picking out. Let's see if I can maybe get a little further away from it. Okay, so it looks like the one that's on the left is closer or bigger than the one on the right. Oh, I think the one on the right is picking up a little bit of the red underneath it there. Anyway, so it should pick out the largest one. And if this is kind of an extreme lighting condition, but
Looks like it froze again, Ray.
yeah,
there.
oh no, it's just not, wasn't finding, there we go.
Okay.
Okay, so now it's the threshold jump to number 4. That's a little too intense. Yep, got a UART fail. I think I've got a bad cord. Anyway, so it can handle a pretty good range of lighting conditions. This is a little too extreme. There's no adjusting the light. But, and the UART failed. I just don't think I have a very good Wi-Fi connection in this room. Yep. And it's in demo mode.
So you're sorting through all the different color thresholds?
Yeah. So it was index 4 is 0, 1, 2, 3, 4 down here, and it was started out at index 0. So it went through a pretty good range of colors, you know, and that's kind of what you could experience, you know, just being under fluorescent lights or something. Or one part of the course is under fluorescent lighting and the other, you know, it's a little further away from it or something.
Those colors, did you pick them using the color picker in the app? Is it like the OpenMV app where you can pick the color?
Yeah, this one has, like, one of the things you can do, you can highlight an area, and the histogram here, I don't know if you saw that shrink, but the histogram now is for the area that you've selected. And so you can set these accordingly. Like, you know, they're 39 to 49 for L and 48 to maybe, I don't know, 58 or so for A, and maybe the same for B, or maybe B is a little more extended, maybe 48 to 60. But just as long as I keep square on the can. So yeah.
So are your thresholds exclusive of each other, or are they additive?
Yeah, they're not really additive. That's the range from, you know, the first one to the last one is, you know, higher and higher brightness. You can see the L component gets much higher. goes from 13 to 75 and 65 to 105. So, you know, as far as that's the L is supposed to be, I don't know if it stands for luminance or not, but it's supposed to be the brightness in the image. And standalone, it's a lot faster. This has a, you know, basically, I guess you'd call it a local area network connection.
Is this OpenCV?
No, it's not OpenCV. It's similar. You know, the functions were defined by either the guys at OpenMV or whoever made, you know, I guess at SciPede. And they're similar to OpenCV statements, but not identical. And so each one has its, you know, its own definition, what the parameters mean, what the ranges can be, how to use them, you know, that kind of stuff. And even OpenMV versus SciPede, you know, they're a little bit different. Like here's, you know, here's the equivalent in OpenMV. So they have, you know, find blobs. This one, threshold. Yeah, they also have a find blobs definition, and some of these are the same. Basically, the code is a little bit different for each one. But like on, you know, the SciPede part, you know, you actually use a serial 0. You call out, you know, which serial port you're using, and it's a serial write bytes for the value, and that's the half of the centroid, because I only wanted to send a byte. So, you know, you can't 320, you can only go from 0 to 256. So if you have an X value of 0 to 320, if you just shift it one bit to the right or divide by 2, and then when you get it back on the other side, you multiply it by 2, it loses one pixel in resolution. But you know, you don't have to parse multiple bytes to try to figure out what it is. So it has just enough information to be able to steer the robot towards the can based on, you know, what that X centroid is, that higher number in this listing here. So anyway, it's kind of neat. You can actually buy, well, I don't know about the later ones. The OpenMV H7, you had to buy a separate card to get a Wi-Fi connection. But this one you don't, it's included. So basically what you can do is you can take this and basically make a package out of it. That's that icon down here. And you can actually load it onto the device, and then you can either create your own little, oh, I don't know what you would call that, your own little logo for the app. If you don't, it creates one for you, and you know it. You give it a name. In this case, I gave it Mech Blob, which stands for Mechanum Blob. So, and then, you know, it doesn't require a computer connection or an internet connection, or you can just, you know, use it standalone pretty much. So, and it's a lot faster, just like the OpenMV H7 is when it's not connected to a laptop. For, you know, for the OpenMV, it was through USB. And it's, it's just a lot faster if you don't do that. And you don't need to anyway, once you've got the app developed and working, or the package developed and working. So it's pretty neat. It's a pretty good device. I think it's going to be fairly reliable in finding cans, probably as reliable as an OpenMV H7 or a PixieCam, because they're all doing the same sort of thing. I mean, you can have multiple signatures, I guess, in the PixieCam, and that can cover, all the different lighting conditions, looking at the cans from one goal versus the other goal, dealing with uneven lighting conditions on top of the, over the course, that kind of stuff. So anyway, got that working a little bit better. So anyway, that was all that I had to show. Let's see if it's still, whoops. Yeah, there it is. Still working. So yeah, the goal to find the one that's closer, or with the larger number of pixels, you want to go for the closest can, because it can, if it doesn't, and maybe the lighting conditions where the robot is change, or it looks, maybe the side of the can that's a little bit darker, it would jump to the next largest one. But you don't really want to do that. You want it to use or go to the one that's actually the closest. And one of the ways to do that is to, like in PixieCams, use multiple signatures, or in this case, multiple thresholds, either for the OpenMV H7 or the MaxCam. Anyway, that was all I had to show.
Thanks, Ray.
Sure.
That's I gave that a black star as well.
Okay.
Call it significant progress.
Yeah.
It's on your multiple different. I always enjoy your varied attempts at can detection and the course, how to find position, how to find detect the cans. I think it's excellent.
Well, good. Thank you. Hopefully you guys can use it. Yeah, one of the things I didn't like on this one, I don't know if you can see that they have that one right up there is find blobs.
Hang on, I will pin that again so maybe everybody can see a
Oh,
little.
okay. It's kind of hard to see, but it says, I don't get a reflection. The one in the middle there is find blobs. And this is one of the packages that comes with it. And it works really well. It finds, oh God, that's all washed out.
Yep.
Yep. Okay. God, that's horrible.
I'm just seeing a washed out image on the camera.
Yeah.
Looks like a telephoto lens on it too.
Anyway, if I could show you with it, it actually does find the cans really well. And they had a set of sliders down at the bottom here, and you could actually adjust the LAB values for what you saw. So, darn, I wish I could figure out a way to do that. It just seems like it's way too bright. You also had a thing where you could exit the app if you wanted to. So you just hit the button in the top corner on the touch screen. Blink. Okay, there we go. Goes black and comes back to the main one. So what I don't like about this is that, okay, that was an app that either SciPede created or somebody else created and then put it into their, public sharing area. But you can't load their app, their code that they made that app with, and play around with it or change it. So you can, you know, put apps or packages onto the thing. You can delete them, but you can't, once one is, I guess, in a package, you can't go in and play with it or edit it. So, you know, that was a little disappointing because they had some neat things in there, the sliders and the, you know, a little button to exit the program if you needed to. So I actually asked Copilot to try to do what they did. And I think it's going to take Copilot several iterations more to actually get to the quality of app that came with this thing, because you know, it threw up sliders, and the sliders you know, wouldn't relay what values were on the slider, so you couldn't set thresholds. I think the exit button worked, but you know, and it took several iterations just to get to that point, you know, to have sliders on it. And you know, I thought, you know, I even asked it, you know, are you familiar with the MaxCam IDE? You know, do you think you could generate code for it? And, you know, I told it what I wanted. And, you know, I said it was okay, look at the find blobs example that comes with it. You know, that's what I want to do. And it didn't do so well.
It probably said, sure, I can do that. No problem. That's a great idea. And I think that's going to be fantastic to go do. And, oh, by the way, I can't do that.
Yeah. So anyway.
Yeah, that's happened to me a lot in the last week or two in a whole bunch of ways. Not happy about that, by the way, but you know.
Well, thanks, Ray.
Yeah. Oh, I also asked Copilot to do basically to try to find the goal opening with a laser line. And I haven't actually played around with those to see if how those would do. Actually asked it to do it for the OpenMV H7 and the SciPede MaxCam. So, and they're, you know, because they're a little bit different, and so I'll have to try one of those to see if it's got a snowball's chance in hell of ever working. So it's you know, I don't know, you know, it's like you know, it generates the code, I try it, it doesn't work, you know, I try to give it some errors that, you know, printouts, whatever they are, and say, okay, well, here's an error, it's not working, can you fix it? You know, it goes, you know, it tries several times, and I don't know, maybe it's just counting on your patience wearing thin and saying, screw it, I don't want to do it anymore. It says, oh, I couldn't have fixed that anyway. But so yeah, that's another thing that you know, that you can do with any of the cameras. Well, probably less so with the Pixie Cam, but you know, at least the OpenMV H7 and the MaxCam, you could do that kind of stuff with. But so yeah, it'll be and it was kind of excited about it. You know, it's like, oh yeah, you know, that's a great idea. I think I can do that for you. So.
Okay, well, that was it for presenters. I don't know if anyone else has something they'd like to present tonight. To open the floor up to open mic, or are we done for the night?
I do have a little bit of something. Promise it'll be kind of fast. If you tomorrow night on my Twitch stream, and if you go to twitch.tv, look up Harold Pulcher, the only one there. We started about 8 o'clock, and I will be, it's the first Wednesday of the month, so I'll be doing something I call Pick a Turn. So of all the people that are there, I'll give them a choice whether I do a pin or not a pin. And then if they say whichever one they say, I'll have 5 selections to do whatever that is. And then when they pick one of those, then we got to put some kind of body on it, some kind of wood or resin or something on it. And we'll make all those choices tomorrow night. And I'll go through each one of the things, explain what the things are and that kind of stuff. And then that starts the ball rolling, because the next Wednesday is when I do whatever it is we pick tomorrow night, and we give that away free. Give that away to whoever. Now, I'm going to give whatever comes off the lathe away. Now, if it's a good thing, great. If it's not a good thing, you're still going to get it. Because I know Ray knows sometimes things come off the lathes in not a good way. Sometimes they blow up. Sometimes they don't. And I have a feeling this will be the 4th time I've done it. And so I got a feeling that last time they picked a pin, and then I showed them all the not a pin things I could have made. And they're going like, hey, can we change our vote? I'm like, nope, too late, bucko. So I suspect this time they'll be more willing to pick not a pin. And when you start doing not a pins, you get things like, it's kind of hard to see. Hold on, see if we can hide it. This is something called a fun cup. Basically, this is overpour resin that I just started packing full of into a cup. And this is one of the things I'm going to offer up to turn. And I've done one of these before. And this is what the result of it was, basically a shot glass of some sort. And that I turned in and turned down and that kind of stuff. The reason they call it a fun cup is because it's not, you're not going to sell or give it away as a gift or whatever. You're going to turn it for fun and do a little practicing on, and this is going to be waste anyway. So that's kind of what to do. So, and this has some really cool colors in this one. So we'll just have to see what's going on, and we'll have to see all that kind of good stuff. So anyway, that's going on tomorrow night, and then the following week we'll be doing the turning of whatever that was. So there you go. That's all. That's really all I got. Really. See, I told you it's going to be fast. When's that happen? And how often does that happen? Oh, and for all of you that are actually following me and giving me likes and my stories and things like that on the gram or TikTok or Facebook, whatever, thank you very much. And if you're not, that's fine too. I can understand not liking it. I'm making a little reach. I get a hater. Somebody called me pathetic. They said, that's not coding. That's using AI. Pathetic. I'm like, so this put up a clip that says, yeah, I'm pathetic. I'm doing more than I could do before, faster. That's called pathetic. Then yes, I'm all about pathetic. So, that kind of thing. But anyway, there's that deal. That's it. All I got.
Some of us, it's not a problem with not liking you, Harold. It's not enough time.
I get it. No. I get it. I absolutely get it. I do absolutely get it. There's only so many hours in the day and only so many things that can possibly happen. And we've got all kinds of sticks in the fire. And
yeah, between
all that kind of stuff. Oh, I get it.
Work, home life, and robots. I only work part-time, and between work, home life, and robots, I'm full.
Yeah, no, I totally get it, man. I totally get it. I wasn't having such a good time interacting with everybody and all that kind of good stuff. Because it's not like I'm making my millions at all on this. I mean, I do make a little money. When I say little, $30 a month or something like that off ad revenue or something. It's all about, I'm going to be in the garage anyway. And if I got people to come along with me, and a lot of times they help,
Does $30 a month pay for your AI usage?
Not really, kind of, because most of my AI usage, I go through my my office account, on that, which is a kind of, there's so many tokens included on it, and I don't use all of it. Most of my AI usage that I do is actually work, and work is paying for that. I go through work license stuff I do on the stream and that kind of stuff, and all the things doesn't amount to very much. I don't reach the cap, so I'm not worried. I'm not too worried about that. I'm not too worried about that because I'm using the free stuff, or I'm using the almost free stuff, and I've got an MVP that gives me so much credit a month or access to like Copilot and that kind of stuff. I set it to either. I'm not using Opus. If I was using Opus, it would become close. But most of the time I'm using the GPT. Currently, I think I've got everything set to 5.4, or in the case of the Copilot that I go in with and go to Copilot, sign in as myself, I tell it to auto, so it uses whatever it has, and sometimes that's a good thing, and sometimes not a good thing. So I'm cheap, and it's able to help me a lot. So I haven't gotten to the point where I want to kick it into Superman mode and start asking it really hard questions. I guess I probably should have a long time ago, but I just didn't. So there's that. Whatever that's for.
Well, thanks, Harold.
Hey, you're welcome. I know it's not a whole lot contribution to this. I'm sorry I missed on Saturday. I was in Kansas.
Oh, you missed a good presentation.
Yeah.
Ilya did a nice one, but it's recorded. It's on our YouTube channel. So.
I should go watch that because I thought that was going to be cool. I actually thought that was going to be cool, and I wanted to be there.
And then the slideshow as well is posted on our Discord server.
Oh, fantastic! I'll go check all that out.
Yeah. So I posted the meeting, I believe, as well. So on Discord, and the slideshow's there, so easy to find. Was that it, guys?
Could
Are
be.
we done for the night?
I'm good.
Okay, guys.
All right.
See you on Tuesday.
All right. Good night.